And now, get ready, folks. It's time for Banter with Bob Sherwood and Dan Snell. Banter. And now, here's Bob and Dan.
Hey guys and gals, here we are. Oh my gosh, what a great day this is. I've got my friend Ian on. I'm not gonna take Ian's whole name. I'll let him do that. He may not want to be associated with us after the banter, right? So by not giving you his whole name, his email address, or his phone number, he can decide to disclaim everything we're talking about. So Ian, remember we banter, right? Now, the background for our audience is that this is the smartest guy I know, and I know a lot of people, so it's not a limited group I'm talking about, on quantum computing. He's extremely knowledgeable in math, and hopefully he's going to be doing a fellowship on his PhD, maybe at another prominent university. I'll let him mention that if he wants. Now, okay, I'm going to start off. What the hell is a qubit?
Okay. Yeah, that's an essential question. Yeah, so a qubit is the kind of thing you would build a quantum computer out of. In regular computers like laptops, you have bits, and bits are usually the hardware for them is just like a little loop of current that either goes, one way or the other. So you got kind of two options, 0 or 1, clockwise or counterclockwise current. And a qubit is kind of the analog of that for a quantum computer. But instead of having only two options, so either 0 or 1, then you basically are allowed to mix the zeros and the ones. So instead of just getting exactly two options, you get a whole sort of circle worth of options, or a whole kind of sphere worth of options, where the points on that kind of geometric object you can think of as corresponding to a certain kind of proportion of 0 and a certain kind of proportion of 1, or a certain probability of 0, a certain probability.
I have no freaking idea what he's talking about.
See now, Ian, here's why we call this show Banter. Because Bob starts
Dan,
off with a question to a guest.
Do you understand it,
He's
Dan?
trying to interrupt me right now. He's trying to interrupt me. Bob, you already understand this because you told me about a month ago that with quantum, there's just not X's and O's, plus and minus. Let me finish, Banter, man. That you start off with that question. What we should maybe do is start with the foundation, because we have listeners who are probably right now going, this looks like a good show. I'm going to like, subscribe, and I'm going to share this because I don't know much about quantum computing. As you said, Bob, 99% of our viewers, listeners, know probably nothing about quantum computing, and those maybe, and at least 90% of them know a little bit.
Yeah, but they're reading about it, and they're gonna. And this guy this guy Ian, we're going to be
Ian
reading about
Gershon
him in the next 10 years.
On me on Math Stack Exchange, Quantum Computing Stack Exchange, Math Overflow. Feel free to upvote my posts. I have 5K reputation on Quantum Computing Stack Exchange, 10K on Math Stack Exchange.
That is powerful.
Qubits. When I first heard of qubits, I thought, where'd that name came from? And I guess it's obvious. It's quantum, Q-bits, right?
Yeah.
Now, it also occurred to me that these qubits, which are really hard to understand. I mean, in other words, if you say the word qubit, I have no image in my mind. I just see the word qubit. Whereas when I see semiconductor, I've got little doors and they open and they shut. But the qubits, everything's open. But because everything's open, doesn't that create a lot more likelihood of errors when you use a quantum computer?
Yeah, so that's kind of the name of the game with quantum computers, is that they're very error prone, which is why we need people like me. I'm looking at you, National Science Foundation, please fund me. We need people like me who study quantum error correction. And yeah, so you can actually do a qubit with the same, with a superconducting, with like a little circuit, the same way you do laptop computers, but usually the current can either go one way or the other way. But actually, if you cool those circuits to like a fraction of a degree above absolute zero, then you get this thing called superconductivity where they can do
Wait a minute, wait a minute here.
yeah.
What's this absolute zero stuff?
So like, how you learn this in high school? It's like negative 273 point something degrees Celsius. It's like really, really cold. It's like
How do you get them? In other
Now,
words,
do you have to have these computers in a cold room like the old days?
yeah,
When
yeah, no, exactly like the
you can
vacuum
freeze your
tube.
butt off.
Yeah, even colder than the vacuum tubes were. I mean, they're making them like even colder than the vacuum tubes were. But yes, that same idea.
So okay, so Banter with the basic question, because see, Bob is just, I admit it, he's a smarter guy. He's got 2 master's degrees. He's taught as a professor.
You finally admitted
Ian,
that.
I got a 2.2
Yeah.
GPA from the University of Nebraska, that citadel of higher education.
Yeah.
In the
Hey,
Midwest.
my collaborator is applying there for a postdoc right now, looking at University of Nebraska.
Okay, stick with me, buddy. I'll help
hire.
you. Anyway, here's my question. Jimmy Jones or Sally Smith, I always talk about them on the street. They hear this term quantum computing. Now, and so in my mind, speed, the ability for throughput, scientific, medical, all the things it's going to do faster, better, brighter. So in a 101, quantum computing 101, Jimmy Jones and Sally Smith would ask you, tell me the basics of quantum computing.
Yeah, so I think they were originally sort of conceived in the very early 80s, maybe even late 70s, by some theoretical physicists who said, I'm a theoretical physicist. I love to study certain systems, small systems, quantum systems, and I like to simulate them on my laptop. You go type, 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 type. I'm going to do a simulation, and you try and run it. And you realize that if you try to simulate more than, I don't know, 100 atoms at the same time, it's like almost impossible. Your laptop just never finishes a simulation. It's so computationally intensive.
The spinning wheel, that's when people see the spinning wheel. Yeah.
The death wheel, yeah, the little like Apple pinwheel thing. That's right. And so all these frustrated physicists in the late 70s, early 80s, most famously Feynman. There's also a Russian guy, I think, who actually did it before him, but no one cares because that guy's like Russian and wrote it in Russian, so he was forgotten. But Feynman and some other very smart people realized this was very frustrating, but in the lab, their postdocs and their graduate students could actually just take the measurements they wanted, given enough time, with even more than 100 atoms, like 1,000 atoms. And so they're like, somehow my students are able to take this measurement and get the right number for a sort of computation that my laptop and even my supercomputer at whatever university I'm at, even my supercomputer can't do this calculation. But somehow, by just evolving, by just letting the atoms sit there, hitting them with some lasers, my grad students can actually get the exact number that I want. So somehow, like nature, when I take my lasers and I bombard these 1,000 atoms and I take a measurement after a couple seconds, somehow nature in that 2-second time is basically solving a question. It's solving a math problem about how the physical system evolves that my computer and even my supercomputers can't do no matter how much time I give them.
Nature?
So people started to think about
nature
this.
Is doing this?
Nature is doing it because
Like God? You mean like God is doing this?
God or nature or whatever. I mean, because you can really just take the measurement and it's solving a very precise mathematical problem.
Yeah.
And it's happening in a matter of seconds. Whereas even if you spend days and weeks and years on a supercomputer, you can't actually solve the same math problem.
So it's that much faster. It's
for certain problems, it's that much faster.
So explain the impact of a quantum computer on current cryptographic technology.
Oh, see, Bob went out on the internet and he said, give me the toughest question you can ask a quantum computer, because he likes to banter. He likes to put people on the spot. Oh, this was on the top of your head question?
Well, yeah, it's one that it's important because as I understand it, we use a lot of cryptographic standards now. They're called STA. They're a certain number of digits. I understand most of them can't be broken by normal computers, but a bigger computer could go through all the permutations and solve them. Is that a concern in quantum computing?
Yeah, so this is where a lot of my money comes from, is that in 1995, this very smart guy, Peter Shor at MIT, this was sort of the first big wave in kind of, I guess, commercialization, commercial interest, government interest in quantum computing, was he wrote this thing called Shor's algorithm, where he figured out that if you had a really good quantum computer, you could, there's something called RSA encryption. That's like a type of encryption.
Yeah, I've heard of it.
Used for like, online, whatever, like when you use your credit card on Amazon or something. And more or less the way it's done is you take two really big numbers that are prime and you multiply them together. And then in order to break the encryption, you have to factor the number. So, 6 is 2 times 3. That's easy to factor. 21 is 3 times 7. That's also easy to factor. But then if you take something bigger, like, I don't know, 17 times 19, that's already like kind of a big number. It might not be that easy to factor that. But of course, they're taking two primes that are each like 1,000 digits long and multiplying them together. And it turns out that that is a really hard problem for computers to solve. If you have two sufficiently large primes and you multiply them together and you try and make your adversary factor the number, figure out what the prime factors were to begin with, it's extraordinarily difficult.
So I want to use a quantum computer and break into the banks.
Yeah.
Will a quantum computer help me do that?
Yeah. If you have a really good quantum computer, then you should be able to, steal everybody's credit card information.
Well, that's exactly what I was hoping you would say, right? And just so now I don't really understand how it works, but let me kind of ask a more basic question. If I'm in your lab and I'm looking at a quantum computer, what do I see? Do I see a keyboard or what do I see?
Yeah, so I mean you can kind of look up some pictures, but they tend to be these like big kind of metal contraptions that try and isolate the qubits from the environment. Because the environment is going to cause errors. So they tend to be like a big metal contraption that has some like wires and stuff coming out of it. And inside, what they're going to do is try and cool the inside to very close to absolute zero, and then they're probably going to shoot lasers at it. That's how most these things.
How do I communicate my question to the quantum?
The way you communicate the question is the lasers. So you cool the qubits to as close to zero as possible so they don't have too many errors. And the way you communicate the question, so you put the qubits in some initial state that's going to correspond to the question you're asking, is you get some grad student to program some script that will shoot lasers at the atoms in a specific way.
And so they're programming that or a prompt on the keyboard, right?
Wait a minute.
Yeah, so I mean, they have, I guess, some like regular computer that is hooked up to their like laser machine. And they're putting in a bunch of commands being like, if you measure that it's off on the z-axis, shoot it with this laser, do this many pulses, then check again. And so they have some just like script for how to use this.
So this is breaking news. This is good stuff. So the leader right now, it seems like I've read IBM is one of the leaders in quantum computing. They're trying to be.
Yeah,
Ian's going to be the leader.
Next to you, there's Ian, and then IBM. They both start with I.
Yeah, that's right.
Ian will show up first because he's IA and they're IB.
Engine optimization built in from day one.
So now this room, so I want to picture this. So it's got to be a cold room like in the old days, mainframe. That's when I started selling it.
The humans are in should just be a regular temperature, but inside that metal glob where the atoms are kept, inside that metal basket, it'll be like absolute zero.
And so the lasers are we got lasers shooting at some kind of a chip or something or a.
Yeah, so
that's a technical question, isn't it? Highly technical question.
There's different hardware
possibilities. Ian looks back and he's thinking, how can I explain this to these guys? That's so stupid.
I'm a kindergartner and you're a graduate student in the knowledge.
This morning, Ian, I'm working with a programmer and determining how to put an image on a website. And now I moved into
lasers shooting it. I've got this picture.
Like I've got a little laser gun. I'm shooting a laser and
so
God almighty.
I got to get Chat GPT to draw me a picture.
Future right here.
Are you having fun, Ian? Are you having fun?
You could. Yeah, no, this is a lot of fun. So you could Google like IBM's computer or like Willow's computer, and it's just like it looks like a bunch of just wires and business. But there's different kind of hardware platforms. So for a lot of I am full disclosure. I have $100 of stock in IonQ, which is a College Park startup. I know some folks that work there, and it's like it was started by a professor from my university, so it's sort of like hometown pride.
I like it.
What's the name of it again?
IonQ.
Can I send you $100?
Sure, you can buy it yourself. Mia's senior year house was right behind IonQ's headquarters. Literally, just like you could walk there in 50 feet.
Really?
Yeah, yeah,
So,
yeah.
I mean, is it a public company or private?
They're publicly traded. Yeah, they're publicly traded.
What's the name again now? Tell me again.
Ion Q. I'll put it in the chat in case anybody
Yeah,
wants to buy it.
INLC, huh?
If you buy, then it's been up 200% since I bought it.
Oh my God.
Ion
Mostly
Chat.
it was down for a while, to be honest, and then Google Willow is such a big success that all the quantum computing companies went way up. So it's not anything special to IonQ. It's just because Google Willow is such a success that all the quantum stock has gone up.
The last year, NVIDIA, which you probably know, invested in about 80 different AI companies, some real small, right? They invested hundreds of millions of dollars. I mean, for them, it's like betting. If you bet on every chip, you're eventually going to hit it somewhere, right? But
Sure.
these kind of companies are the ones that are going to make millionaires.
So
because somebody's going to figure out how to do it. I remember and I lived in Los Altos, so that's where Steve Jobs lived in Wozniak, and all of a sudden we started talking about, computer circuit boards and what they could do, and I thought, wow, that's pretty interesting. And that's like this discussion. This
discussion
is equivalent to the computer discussion of 1980.
I would like to think, because Bob and Ian doesn't know, but I live on ADD. I live on ADD Avenue, and so my brain is always going super fast. So could I say, instead of saying I have ADD, I have a quantum computer mind because I go so fast at processing?
Yeah.
Sure, why not?
That's my story, and I'm sticking to it.
Revolution, Dan Snell.
Nope.
You have the capability of saying that you can think of the same thing and it's opposite at the same time.
That's right. So, okay. So serious. We have a lot of fun here. But so what would be the most practical thing? Let's say, would you say within 5 years, 10 years, will be this, as Bob and I always are. In fact, 2 years ago, December 22, we did weeks of free on Chat GPT on AI. We did that for the American public. Now we're doing it again, Bob. We're doing it again with quantum computing. We're bringing the people early. So what's going to be the first things people will see? Will it be 5 years, 10 years? What do you think the first thing we'll see?
So, I'm not that well-informed. I'm more well-informed than the overall majority of people. But compared to folks in my area, like I don't do hardware, right? So there are certain people who actually work on the hardware systems. They worked on trapped ions, which is what IonQ does, or they work on superconducting circuits, which is what Google Willow does, or they work on, neutral atom quantum computing, which is what like Psi Quantum does. So like there are people working the actual hardware, and they're much more finger on the pulse for like how fast this stuff is really happening. I do more of like the theory stuff. So my guesses are like mostly armchair speculation. But if I had to guess, I don't think that a good enough quantum computer that it'll actually be able to like steal people's credit card information. I don't think that'll happen anytime for many, many decades, if I had to guess.
Really?
Really? So you think it'll be 10 plus years out, huh?
So my credit card is safe.
Your credit card is safe. And not only that, rest assured that your taxpayer money is at work right now at the, NIST in Gaithersburg. All these people are working what's called post-quantum cryptography. I know many of these wonderful folks. Really? And so they think about how can I encrypt your credit card information in a way that even a quantum computer couldn't.
And the government is helping fund some of this to protect us from the Russia, and China.
Yeah, exactly. Yeah, no, they fund lots of fantastic folks who work on post-quantum cryptography.
Would you say America's ahead right now, the rest of the world in quantum computing?
Oh yeah, I mean way ahead. Like way.
There we go. Good American.
Yeah. The Russians aren't even interested. The Chinese, I mean, you never know. Maybe behind closed doors, they're like making leaps and bounds. But the general impression I have is that the Chinese
are waiting for to hire you.
That they're gonna lose the race to actually build a quantum computer, and so what they're doing is more stuff like kind of defense stuff. So like quantum secure communication and stuff like that.
Okay, guys and gals and listeners, now we know your credit card is safe. I thought you were all in danger, and I was really on this cryptographic point, but now I see, hey, Ian says we're in good shape. Now, if it turns out your credit card is stolen next 4 years by a quantum computer, then we'll need to know how to locate Ian.
Yeah. Then you can really read me the riot act.
That was great. You are such a smart, talented guy. And now this is going to sound like a an interview question, and it's not. But I'm curious. You're in this business, right?
Mm-hmm.
Uh, where do you see your job in 10 years?
I mean, I really like just like universities and academic stuff. So I would love to just like be a professor and just like hang out and do research and teach. That would be super cool. Um,
Right.
if that,
In other words, from your perspective in your business, you see the academic component to being the most interesting area for the next probably 10 years, right? The academic
well, I
part of
mean,
it.
I think there's some
Research, the
truth to
study.
that just because we're so early, like you were saying like, oh, it's almost like we're in the 80s in terms of computers. A lot of people say it's more like
Right.
we're almost in like the 60s or something. Like really,
Really, yeah.
really,
Yeah.
really early days of like computational machine
Yeah.
learning. And given how early we are, I think there's some truth to the idea that commercialization is going to be tough, and a lot of the most interesting things are still happening sort of at the theoretical level. But even putting that aside, everyone's just different. And I personally am not a huge programmer. It's just like not my cup of tea. And if you want to do really
But
serious
what are you
goal
doing? Like in your capacity, like you get up in the morning and you have all
uh,
this expertise. What do you do? Do you sit down with a pencil and paper and start designing stuff, or what do you do?
well, I'm
Excellent.
always looking for a new. I mean, I do use pencil and paper. I'm always looking for a new and better quantum error correcting code because we
Because
gotta
that's a
keep.
key. Error
That's
correcting
your
seems to be a
It
buzzword
really
in
is.
the.
It's the biggest thing right now, I'd
It's
say.
going so fast because it's
Now,
going
what
so
does that mean?
fast.
Code? Does that mean like Python code, or what kind of
Oh,
code are
so
you
so
talking?
sorry. Yeah, that's a weird homonym in the English language. They're just totally different. So there's a quantum error correcting code is a code in the sense of like uh I don't know if you like talking pig Latin. That's kind of like a code because people can't quite tell what you're saying.
Ixpe Attenley?
Yeah, there you go. There you
Erive
go.
Ufe Ixpe Attenley. Igpe Attenley.
So I do things that are like almost kind of like ciphers. I like encode things in a way that makes them hard to understand or hard to, to eavesdrop on or whatever. Whereas coding in the colloquial sense of like, oh, I'm a coder, I work for Google, is like you write you write instructions for a computer.
Yeah,
Uh, so you write like, yeah, functions for a
that's what
computer.
I think of code, right?
Yeah, so that I don't do a lot of that type of code, like regular
Yeah.
coding.
So,
Well,
I'm sort of quantum
it,
in
and you
if
yeah.
you're
mentioned,
looking for this new quantum computing error code,
Yeah.
where are you looking? Like in your kitchen or on a piece of paper? Where do you look for it?
Yeah. So, I mean, these things are all at the end of the day just lists of numbers. So
Hmm.
you want to sort of pick the right list of numbers that has some good properties with respect to like certain matrices. I do basically fancy linear algebra. If you ever knew people who took linear algebra in undergrad, like,
I
just like
did.
matrices. There you
I
go.
took
You
linear
know
algebra,
yourself.
right?
I
So
got a
I work
C
with big. Hey, that's
minus,
a passing
C
grade in a lot
minus.
of places. You can get credit for that still. Uh, so I do some computerized work, but mostly I do theoretical work where I say, I think a lot about sort of the laser side of it. So there's always a balance with quantum error correction. On the one hand, you want to isolate your system so it doesn't get
Yeah.
messed with and it doesn't get ruined. On the other hand, you can't isolate it too much because if you isolate it too much, you'll never be able to give the instructions that you need to your quantum
Right.
system. You'll never be able to program in the kind of problem that you want to solve. You need to ask a question to your quantum system.
Mhm.
So on the one hand, you don't want errors, you don't want noise, you don't want electromagnetic radiation, you don't want
Right.
like whatever people's waves from people's fucking
Yeah.
cell phones, like whatever it is that might mess with your qubits. You don't
Mhm.
want that to get in there and mess with them. But when you have something to say to the qubits, it's important that you're able to talk to them. So it's a weird balance where on the one hand, you want to isolate them as much as possible, but on the other hand, you want to be able to tell them certain things in certain ways that they will hear you.
Oh, it's kind of like AI. If you ask a question, a prompt of AI, if you ask it wrong, it's going to totally, you're going to have to do it 5 or 6 times. So
Yeah.
you got to do it with the qubits. You got to,
Yeah, you got to be careful for sure about how you do it right.
So for our listeners, we always ask you to like, subscribe, tune in, share this, and we're going to keep going here. But I want to make sure I pronounce, because Bob, you know, Ian Gershon Teixeira, pronounce your last name for us.
Teixeira.
Ian
Yeah.
Teixeira. And we'll ask you at the end, but is there any place they could learn more about you?
Too, right. $3,000. This guy's going to charge $3,000 an hour in 10 years.
That's right.
If you can get him.
Yeah.
Right?
There you go. Yeah, you guys are here on the ground floor.
No, well, I can tell you a quick story or so. In 1980, I'm at a party. I'm with my wife, Helen. You met Helen, I think, Ian. Anyway, we're standing next to this guy. He's kind of a laconic guy, doesn't say much. Helen says, "Who is that guy?" I said, "Well, I don't know. It's some guy. His name's Bill Gates or something, and he's started this company called Microsoft, and they're doing some product. I don't know, like an Excel or spreadsheet or something, but nobody thinks it's going to work."
That's it. We know you, right? Ian. We know Ian. We're going to say Bill Gates.
This is Bill Gates.
This is it. So who would be besides you, Ian? There's Ian. Then who under you would be some of the thought leaders or the big names in quantum computing out there that people might keep their heads up for?
Yeah, I mean,
that's a good question. I'm surprised, Dan. That's a good question for you. You must be studying hard.
Ian, just so you know, my mind, you know what this is? My questions usually are, do you know exactly how to eat an Oreo? And it's not.
Oh, that looks delicious.
It's not quantum computing. It's, do you know how to eat an Oreo? So we're going to higher level. So, okay, I didn't mean to interrupt. Who's the big names besides you?
Yeah, I mean, the big names, I guess, in terms of like the companies is, I don't know, like whoever owns the quantum part of Google. Like, I don't really know people in the corporate world so much. I know people in error correction. Sergey Bravi is like, he was at Microsoft for a long time, and then Microsoft fired all their interesting theory people, and they were like, we got to be more practical. Super lame. So Bravi is now, gosh, maybe at IBM or something. All their interesting theory people left, like Zhongwen Ha also left. Google's
and IBM, you think, are two big names in the watch.
Yeah, I think the Google is obviously, so Google just did this Google Willow thing, which was like an enormous deal. And so they seem to be ahead the most. No names, but I know multiple people who work at Northrop Grumman. Obviously, it's a lot of like non-disclosure agreements and all that because they're a defense contractor.
You could tell us, but you'd have to kill us.
Yeah, I can tell you I'd have to kill you, but I hear supposedly they're doing really good stuff. Obviously,
wait a minute, there's a cruise missile. I feel like it's coming around. Yeah. I hear it outside. I've been
with a Reaper drone immediately.
What I'm thinking to myself is that I want you, Ian, to interview me for a quantum computer job. Let's say you work for the ABC Corporation, and I'm applying for a job. What would you ask me to determine what I know?
So you want to be like actually part of the team that's like designing the hardware? Is that
I do.
You're like, all right, I'm Robert Sherwood. I want a job designing hardware for you. Okay, so
how do you go ahead?
You would ask like, okay, our company works with this type of hardware platform.
Yeah.
It's like neutral atom computation.
Yeah.
Like, what's your background with neutral atoms? Do you have background either working directly in a lab environment, or do you have any background designing simulations? If so, like, what languages do you program in? And then historically, do you have any? A lot of times people are interested in people who have experience with like quantum tomography stuff. That basically is, how do you tell if your measurements are kind of measuring the thing they should be measuring?
Yeah. So that's the question. The question that got me, I mean, I knew the answers to all of them except for one.
Wait a minute. Okay, Bob, explain neutral atoms to me, Bob. I knew the answer. Okay, Banter fans, you heard it here. Bob Sherwood says, I knew the answers to all of them. Okay, go ahead, Bob.
Except the neutral atom. I have no experience with neutral atoms.
The first one you said. Notice he goes down the list. The first one you said.
Neutral. Okay. I'm trying to think. what's a neutral atom? I mean, where did I get experience of that? Like I've got this pile of atoms in front of me, and one is neutral.
Okay, so luckily for you, very few companies do neutral atom. I think it's like just, oh boy, I could be saying this wrong, but I think it's PsiQuantum that does it. But it's one of the less popular hardware platforms. It just means like they're instead of being a charged ion, because a lot of times people want to use magnets, say, to like kind of squish all their atoms together in a nice way. So then you want to charge particles so that it'll like, interact with the magnetic field and just like you can control it that way.
Yeah, sure.
But there's something nice about neutral atoms, which is that because they don't repel each other, because they don't have charge, you can squish a zillion billion of them into a really small area. And there's something advantageous about the fact that they're not interfering with each other. And so some people think that could be an edge. It is not the majority approach at this point. Very few people.
If you took all the atoms in my body and squeezed them together so they had no room between them, my body would be the size of a little pinhead.
Yeah, that's true.
Because there's it's a very interesting concept. Like, for example, I can see my body in 3D, but if I would eliminate all the spaces between the atoms, I couldn't see myself, or no one else could see me.
It's like water. If we take, what is our body, 92% water? I don't know. Yeah. I only got a C in anatomy and biology too.
Right.
Oh, come on, dude. What's your best class? You must have gotten not a C in something.
This is listen,
basketball.
I think we've taken enough of Ian's time. The guy is
fun,
right on the leading edge, and it reminds me again of my conversation with Helen was with me in that story in San Francisco. And in those days, just one piece of background, the most popular operating system, of course, was not Microsoft. It was a firm called SCO, Santa Cruz Operations, out of Santa Cruz. Nobody even knows now what they did, but they were the most popular operating system. And Xerox was the leading computer company with their little Xerox 880, right? Now, Xerox, you can probably, Elon Musk can buy Xerox with his petty cash fund now, right? Nobody even knows. Xerox owned Park in California. They developed all kinds of things. Anyway, Ian, listen, I want to thank you very much. I know your time is very valuable. I'm hoping that people will look back on this in 10 or 15 years. I think you're, if you get married someday and have kids or not have kids, if you do have kids, your kids might look back on it in 15 years. Maybe your grandkids will. And I think it'll be kind of interesting.
Hopefully.
Yeah. To see what we thought on what's today, January 14th, 2025. One of the few years where if you add 20 and 25 together, you get 45. And if you square 45, you get 2025.
Whoa.
Bob likes that. He likes that square.
Work on that one, Ian, right? Because
yeah. That's his supercomputer brain figured that out.
But we are one of the few years, right? And also, it's where if you cube 1 cube, 2 cube, 3 cube, 4 cube, up to 9 cubed, it equals 2025. And it's one of the few years where those two things exist. Now, I'm throwing that at you. I expect Ian to be correcting me on that.
Bob Quantum Brain Sherwood, that is. Bob the Quantum Brain.
Ian, thanks very much. Ian, if you have a closing remark, we'd like to hear it. Otherwise, we'll turn it over to Dan and see what he has to say. Do you have any closing comments?
My closing comments are quantum error correction is the future. And if I said anything that wasn't accurate, hey, I did my best. I'm not really a hardware.
He's already a disclaimer. He's
not
Number 3, my friend Eric right now is interviewing at Michigan State University for a faculty position.
Right.
Michigan State University, hire him. I'm looking at you.
You'd be a great professor because people want
closure, Dan.
People want to have people to learn from that have enthusiasm and energy and love what they're doing. And you have that on your face, your countenance, your brain, and it's been great. And so what's going to happen is in the next months or year, we'll hear some breakthrough in quantum computing. We'll ask you to come back and bring us up to date on Banter, and we'll let you get a word in as right. But in the meantime, folks, listen, subscribe. Quantum computing, you want to share this one. You want to share this one, folks, with all your friends out there. And Remember Ian, name's going to be in the future. Big name you want to know and remember that name.
Yeah.
Okay, everybody. Thanks for watching.
Bye, Dan.
Stay
Bye,
tuned.
Ian.
Thanks, Ian.
Have a great
Stay
day and a
winsome.
great week.
You're a winsome guy.
And even though you're from Baltimore, go Chiefs.